All right, so we're looking at an equation problem. This is probably one of those questions. I'm not even going into the t, guys, and what's the t talking about here. All I know is that we have things and situations here where we are looking at, maybe proportional, non-proportional, that kind of thing, direct variation situations and so on. If you're a student watching this, this is one of those probably direct variation problems. I see a y, I see an x, I see all that good stuff. I do know one thing. I got 90 cycles, 90 cycles in 2 hours. We taught you things in sixth grade, like independent and dependent, right? X is my independent. Y is my dependent. And one thing we should have taught you is that Y depends on X. Independent variable, dependent variable, and so on. Most of the time in mathematics, X is always time. Very rare that X is not time, which means a lot of your graphs, when you graph things, time is the X. Distance is your Y. In this case, we're not going to measure distance, but we will measure the number of cycles, right? So that'll be your Y. It even tells you down here, well, maybe, we're not really sure if this is even correct because it's an answer choice. But we know one thing, that most everything depends on time. So my hours will be the X, and then the cycles will be that. I'm going to skip, I'm going to put here a 0, I'm going to put here a 1, here a 2. And I know one of them, I know the 2. At 2 hours, I got 90 cycles. This should be an X. This isn't right great, this drawing tool from TA. I wish it broke better. Well, after 1 hour, what will I pay? Or how many cycles will I have here? Not what will I pay? I don't know where I got that from. But anyways, it's 45. It's half of it. Okay? And then at 0 hours, I have 0 cycles. So I already have numbers here. At X is 0, Y is 0. That's proportional. That's going to be that whole K and all that stuff, guys. All right? So now I can use K and say, okay, I'm going to have Y over X for K, which I can use 45 over 1 or 90 over 2. And I was given a 90. And so what is 90 divided by 2? 45, which means Y equals 2. 45x. So we're going to an equation, which is not this one because it's x equals. And it's not this one because this says plus 45. And this guy is, if I graph it, at 0, 0, I start here. At 1, I get 45. At 2, I plot 90. And I got that direct variation thing going on right there. Okay? At 3, what am I plotting? Well, add 45, right? To this guy here, because you're always adding 45. Plus 45, plus 45. That's where the confusion happens with this one. It's not that. Okay, because you're multiplying 1 times 45. You'll intersect that. So it's 45 times 2, 45 times 3. Work it out. You're going to get 135, right? So I'm looking for this guy here. So it almost matches this guy. So it's going to be 135 here. And that points up here. And you just keep plotting right there. So there it is. I'm showing you a table. We got a graph. We got an equation. One of those is my answer. Okay, but the thing is to understand that this guy will hit that origin. So start right down here. We're going to look at it right there. It's this guy. Now, let's make sure it's not the other one. At 0, it's 45. No. What did we get with our graph? And right now, this thing's being super moody, and it's not letting me really work within the system. What do we get? Yeah, no. We got 0, 0. Because if you're not moving, if it's at 0 time, we haven't done anything, there's no cycles happening. So you cannot have that going on, right? That 0 and 45, which means you can't have that going on. If this is y equals 45x, it'd be the answer. The only thing that's matching right now is the table. So that's the only representation that works right now, is our table, which I worked out, which is right here-ish, right? And that's it. Not that it's a difficult question, but it's one of those that I need you to thinking it out a little bit while you're working it out, right? Don't rush into an answer. This is a very doable problem, very easy.